Before we go deep, here's the quick breakdown. Neutral and ground are bounded only at the service panel. In a subpanel, the neutral must be isolated from the ground. If you bound them together in a subpanel, you create parallel return path, which is a code violation and safety issue. Now let's break this down properly. Grounding stabilizes the system. Bonding provides the fault current path. Neutral bonding happens only at the service equipment. Subpanels require neutral isolation to prevent parallel current path. Rule 10-204, grounding connection for DC system. And it goes on to state, DC systems that are to be solidly grounded shall have the grounding connection made at a single point as close as practical to the supply source. It also says to see bulletin 4-3-10, 10-10-19, 10-15-6, 10-22-5, 10-23-4, and 10-24-2. The rule states the grounding conductor of a solidly grounded AC system supplied by the supply authority shall A. be connected to a grounded conductor at one point only at the consumer service. B. have a minimum size as specified. 1 for a bonded conductor and 2 for a neutral conductor when the grounded conductor also serves as a neutral. C. be connected to the equipment bounded terminal by a system bounding jumper. And D. have no other connection to the non-current carrying conductor parts of the electrical equipment on the supply side or the load side of the grounding connections. When I go over to the first bulletin, it states rules 4-004, 4-0118, 10-210B, minimum size of service neutral for single dwellings. Rule 6-308 permits the use of a bare neutral conductor in a consumer service subject to the restriction of the rule. A bare neutral having sufficient ampacity to carry the unbalanced load is permitted by Rule 4-018. When installed in a raceway, a bare neutral conductor shall be considered to have the same ampacity as a conductor with insulation of the same temperature rating as the underground conductor as per Rule 4-0183. This means that the neutral is sized purely on the basis of unbalanced load and will be the same size whether bare or insulated when installed in a raceway. As per Rule 4-0183B, the neutral conductor size shall be not less than the minimum size of grounded conductor required by Rule 10-210B. That is the same as the bounding conductor size as per Rule 10-616. A service neutral also serves as a low impedance fault return path to the utility source where a bounding conductor is not provided. The minimum size of the service neutral is based on the allowable ampacity of the underground circuit conductors, corrected or adjusted in accordance with Rules 4-004 and 4-006, not the ampere rating of the electrical service as per Rule 10-6162. Service conductors for single dwellings and feeder conductors supplying single dwelling units of row housing of apartments and similar buildings are permitted to be sized in accordance with Rule 4-00426 and Tables 39, based on Rule 4-00426. Service conductors are permitted to be sized in accordance with Table 39 if they have a 90 degrees Celsius insulated rating, maximum calculated load of a demonstrated load does not exceed the 75 degrees Celsius ampacity of the conductor. Hence, the service neutral is permitted to be sized based on 75 degrees Celsius ampacity of the underground service conductor. Rules 10-208, conductor of an AC system to be grounded, also says to see Appendix B. And the rule goes on to say, 1. The conductor of an AC system to be grounded shall be A. One conductor of a single-phase two-wire system, the identified conductor. B. The mid-phase conductor of a single-phase three-wire system, which is the identified neutral conductor. C. The mid-phase conductor of a multi-phase system having one wire common to A phases, the identified neutral conductor. D. One conductor of a multi-phase system having one phase grounded, the identified conductor. And it also goes on to say the mid-phase conductor of a multi-phase system having one wire coming to all phases, the identified neutral conductor. One conductor of a multi-phase system having one phase grounded, the identified conductor. And E, the mid-phase conductor of one phase of a multi-phase system, which is called the identified conductor. For the multi-phase system referred to in Subrule 1, E, only one phase shall be permitted to be grounded. So now we're going to get into equipment bonding. 10-600, bonding for fixed electrical equipment. And the rule goes on to say, 1. Except as permitted by Subrule 2, non-current carrying conductors part of electrical equipment shall be connected to a bonding conductor. 2. Non-current carrying conductor parts of extra low voltage electrical equipment shall not be required to be connected to a bonding conductor. Also tells you to see Bulletin 2-12-14. Rule 10-602, conductors in parallel runs. Where conductors are installed in parallel in separate cable raceway or busway, a bonding conductor shall be installed with each group of parallel conductors. Rule also tells you to see Bulletin 2-12-14. Rule 10-604, bonding continuity for service equipment, states see Appendix B, also see Bulletin 10-15-6, see Bulletin 10-22-5. The rule goes on to say, the bonding continuity for service raceways, cable armor, cable sheet, and all service equipment enclosure containing service conductors, including meter fittings, boxes, or the like, shall be assured by A. Threaded coupling and threaded connections to the conductive enclosure with joints made up tight where rigid metal conduit is used. B. Couplings and connectors made up tight where electrical metallic tubing is used. And C. Bonding bushing supplemented with a bonding conductor where the connection to the enclosure is made using standard lock nuts. 2. Notwithstanding Subrule 1C, a bonding bushing shall not be required for cables assembled incorporating an internal bonding conductor in continuous contact with the cable armor, provided that the internal bonding conductor extends from the cable and connects to the service equipment. Rule 10-606, bonding continuity at other than service equipment, also tells you to see Appendix B. And the rule states, 1. Bonding continuity of metal raceway, metal sheeted cable, or armor shall be assured by one of the methods specified in Rule 10-604 or by using A. Standard box connector made up type, B. 2 lock nuts, one inside and one outside of boxes and cabinets, or C. 1 lock nut and a metal conduit bushing, provided that the bushing can be installed so that it is mechanically secure and makes positive contact with the inside surface of the box or cabinet. 2. Reducing washers shall not be used to maintain the bonding continuity of the wiring system. And then it also tells you in Rule 10-608, loosely jointed metal raceways, where a metal raceway serves as the bonding conduit, conductor, and expansion joints and telescoping sections are installed. The electrical continuity of the raceway shall be assured with a bonding conductor. Rule 10-610, bonding means fixed equipment, tells you to see Appendix B. Rule 10-606 ensures bonding continuity so the fault current can return to the source. Rule 10-610, bonding means fixed equipment. See Appendix B. The bonding means for fixed equipment shall consist of one of the following: are effectively metallic interconnection between fixed equipment consisting of metal raceway, metal sheet, or cable armored, except armored as specified in sub-rules 2 and 3. The sheet of the mineral insulated cable when not of copper or aluminum as specified in sub-rule 4, or where the raceway or cables are run underground, run in locations coming within the scope of Section 22, or otherwise subject to corrosion. B. A bonding conductor that is run with circuit conductors as a part of a cable, or C. A bonding conductor that is run with circuit conductors installed in raceways. 2. The armor of armored cables incorporating a bonding conductor shall not be deemed to fulfill the requirement of a bonding conductor except where both the armor and the bonding conductor are in continuous electrical contact. Unless otherwise marked, the armor of flexible metallic conduit and liquid type flexible metallic conduit shall be deemed to fulfill the requirements of both the armor and the bonding conductor are in continuous electrical contact. Unless otherwise marked, the armor of flexible metal conduit or liquid type flexible metal conduit shall not be deemed to fulfill the requirements of a bonding conductor, and a bonding conductor shall be run within the conduit. 4. The sheet of the middle insulated cable, when not of copper or aluminum, shall be deemed to fulfill the requirements of the bonding conductor, and bonding shall be by the method as specified in sub-rule 1. When single conductor cables are used for fixed equipment and the metal armor of or sheet of the cable has been isolated from the equipment at one end in accordance with Rule 4-008, a separate bonding conductor shall be installed for the fixed equipment. One of the most common electrical code violations is bonding the neutral in a subpanel. It seems harmless, but it can create parallel current path and fail inspection. Let's look at why the neutral must be isolated in a subpanel. Before we go deeper, here's the quick breakdown. Neutral and ground are bonded only at the service panel. In a subpanel, the neutral must be isolated. The grounding bar is bonded to the enclosure. Mixing them creates parallel return path. Now let's break this down properly. The most common mistakes is leaving the bonding screw or bonding strap installed in a subpanel. Neutral bar connected to the panel enclosure. Ground bar also bonded. These are bad habits that should never be followed. It should always be best to follow the OESC 2024. This creates parallel returns path for neutral current, which violates electrical code and can create dangerous circulating current. Failure 2. Neutral and ground on the same bar. Another mistake is landing neutral and ground conductors on the same terminal bar in a subpanel. Neutral must always be isolated. Your ground bar must be bonded to the enclosure. Neutral carries current. Ground should only carry fault current. Failure number 3. Missing equipment grounding conductor. Sometimes installers run a feeder to a subpanel but forget the equipment grounding conductor. Only hot conductors are neutral run. No grounding conductor back to service. If a fault occurs, there is no reliable path for current to return and trip the breaker. Remember this rule. Neutral is bonded at the service but isolated in the subpanel. One of the most common electrical code violations is bonding the neutral in a subpanel. It seems harmless, but it can create parallel current path and fail inspection. Let's look at why the neutral must be isolated in a subpanel. Before we go deeper, here's the quick breakdown. Neutral and ground are bonded only at the service panel. In a subpanel, the neutral must be isolated. The grounding bar is bonded to the enclosure. Mixing them creates parallel return path. Now let's break this down properly. The minimum size of the service neutral is based on the allowable ampacity of the ungrounded circuit conductors, corrected or adjusted in accordance with rules 4-004 and 4-006, not the ampere rating of the electrical service as per rule 10-6162. Service conductors for a single dwelling and feeder conductors supplying single dwelling units of row housing of apartments and similar buildings are permitted to be sized in accordance with Rule 4-004-26 and Tables 39. Based on Rules 4-004-26, service conductors are permitted to be sized in accordance with Rule Table 39. If they have a 90 degrees Celsius insulation rating and the maximum calculated load or demonstrated load does not exceed the 75 degrees Celsius ampacity of the underground service conductors. The following is an example of determining the minimum size of a service neutral conductor for single dwellings. So again, Rule 10-204, bonding of service equipment. Neutral is bonding to the enclosure at the service panel only. This creates the fault current path back to the source. At the service equipment, the neutral is bounded to the enclosure in accordance with Rule 10-204. Rule 10-210 requires bonding conductors to provide a continuous fault current path. Rule 10-606 ensures bonding continuity so fault current can return to the source. Rule 10-208 metal parts must be bonded so they cannot remain energized during a fault. Neutral is bounded at the service but isolated in the subpanel. So this is a real example plus recap plus next series segment. Here's a real example inspectors see all the time. A subpanel is installed in a garage or basement, and the installer leaves the bonding screw in place. That means the neutral bar is bonded to the enclosure. At the same time, the grounding bar is also bonded to the enclosure. Now both the neutral conductors and the equipment grounding conductors are connected together in the subpanel. This creates parallel current path. Neutral current can flow on grounding conductors and metal raceways, which is a code violation and a safety issue. So remember, the key rule: neutral is bounded only at the service equipment. In a subpanel, the neutral must be isolated and the grounding bar is bounded to the enclosure. So, in the next Masterclass episode, we're going deeper into electrical installations and looking at common grounding and bounding mistakes electricians see in real jobs. These mistakes often lead to failed inspection and dangerous installation. Make sure you're subscribed so you don't miss the next episode.